So solving simultaneous linear and quadratic equations. We're going to do two examples of this. The first one will be algebraically, the second one will be using the CAS calculator. So this example is using algebra to solve simultaneous linear and quadratic equations. Example 3AA. Solve the following pair of equations. Y equals 2x squared plus 5x minus 15 and y equals 2x plus 3. There is an error in this question. The first equation should be y equals x squared plus 5x minus 15. So remove the 2 from in front of the x squared. First step for solving linear and non-linear simultaneous equations. You need to label your equations as equation 1 and equation 2. Using this, you're substituting one equation into the other. Because these are both in the form of y equals, it's a simple substitution where we'll end up with 1, or equation 1, equal to equation 2. So x squared plus 5x minus 15 is equal to 2x plus 3. You want to rearrange this to make it equal to 0, so we have x squared plus 3x minus 18 is equal to 0. We now need to take that solution that we've got there of x squared plus 3x minus 18 and factorize it. So we're trying to find the x values of this. So when we try to factorize this, what multiplies to give negative 18 and adds to give 3 is positive 6 and negative 3. So factorize this is x plus 6, x minus 3, and it is still equal to 0. Because it's still equal to 0, we can apply the null factor law. So we make the first bracket equal to 0, x plus 6 equals 0, solve for x, getting x equals to negative 6. Again, second bracket, x minus 3 equals to 0, solve for x, getting us x equal to 3. This tells us that the x coordinates of our solutions to these simultaneous equations is negative 6 and 3. We're just now up to finding the y, or the corresponding y values for those x values. In order to do this, we're going to substitute x equals negative 6 to start off with into equation 2, and I've chosen equation 2 because it's our simpler equation. It would work if you chose equation 1 though, and I'm going to solve to get y. So when I do this, I'm going to have y equals to 2 lots of negative 6 plus 3, which tells me that y is going to be equal to negative 9. I do exactly the same thing, but now I'm going to substitute x equals to 3 into the same equation of 2, and then solve for y, giving me y equals to 2 times 3 plus 3, which is 9. The last step that we have to do is to take our solutions that we've just found and to write them into coordinate points. So we have a point that's at the x value of negative 6, and the y value of negative 9, and a point that's at the x value of 3 and the y value of 9. So we write these as coordinate points of negative 6, negative 9, and 3, 9. Box that as our end answer. So the two pairs of equations, x squared plus 5x minus 15 and 2x plus 3, both exist at the same time, or meet each other at negative 6, negative 9, and 3, 9.